is Don Zunard. I'm here today to talk to you about how to avoid unnecessary expenditures to solve SLA issues, also known as fixing bad WLM policies. I found a lot of customers having old policies that really need updating, and they're kind of afraid of changing them. And I want to show you simple ways to detect issues or risks in your policies and how to correct them. So today, like I say, I want to talk about is auditing your WLM policy. I want to talk first, why is your policy obsolete, so that you understand. You really need to look at it. I want you to have a basic understanding of what WLM does in case you don't know it. There are courses out there on that. And then I want to talk about auditing your policy for risk, discovering your obsolete rules, understanding what the risk of those rules are, and then after you've decided to make a change, how to test your policy, because a lot of people deploy policies in low season and they don't actually get tested until high season. And then you go, what's wrong? We didn't change anything in the last 3 months. So we'll talk about how you can actually test your changes. So as always, we have a legal disclosure here that anything we talk about in terms of future is, up to change. There's probably some copyrights in here as well. So why is it obsolete? Many of you have had the same WLM policy for years, and you go with the slogan, if it's not broken, don't fix it. But that personally, I've written some policies, and one of my policies is 10 years old. I'm going to say it's obsolete. So don't be arrogant or scared about looking at this. And I want to say it is broken, and it's broken because the hardware has changed. It's a lot faster. The software has changed. IBM and Rocket have, improved things such that, things run faster. And it was probably wrong in the first place because it was never really tested for the reasons I'm going to discuss in the testing a little bit further. So don't be afraid of the unknown, and don't say, well, I don't understand, it's too risky to change. Once you realize it's wrong, what's the risk? And I'll tell you how to understand that, how to make simple changes, tested changes. It may be an iterative process if you're timid, but you can make dramatic improvements with small farm changes. So, you have workloads, important workloads, PIX, IMS, DB2, and you get customer complaints that the SLAs are being met. And I've seen SLAs being missed, and it's not the same as your WLM goals are being missed. And the top reasons that I've seen that people have issues with the WLM goals is, one, it's too loose. In other words, it's too easy to make, and you could steal resources from these workloads, and they still make their goals easily. I have customers with response time goals where the actual response time is 20 times faster than what they're asking for, which means that push comes to shove in the system, you get it under stress, WLM will let the response time get 20 times worse before it steps in to fix it. That's probably not what you want. It's too tight. It's not unattainable. WLM, it tries to be fair, and it's not going to throw resources at some workload if it doesn't improve it and it causes a lot of pain to others. So it doesn't fix it. It just gives up on it. So you need to make your goals reasonable, obtainable, otherwise you won't work towards them. And the final reason is it's too slow to react. This is rather rare. It basically happens when your workload goes from 0 to 60 in 2.3 seconds, such as the stock market opens. And WLM Group added something called CPU critical to help address this, because what could happen is some low important workload was put above a high important workload because the high important workload was making its goal because it wasn't doing any work. And it would take 10 to 20 seconds occasionally to try for it to make adjustments, and that the stock market people didn't like that. But now IBM in the next version of ZOS is making CPU critical for important one workloads the default. Which means if you had some workloads that were CPU critical, all your important ones are now CPU critical, and your importance 2 won't ever be put above importance 1 anymore, and it might suffer. I think the reason that they did this is people were complaining that, oh, I've got an important one workload experiencing CPU delay, right? That couldn't happen. And the real reason for that was issue number one, your goal was too loose. So I could spend an hour on CPU critical, but we're not doing that here today. So today's topic is items number 1 and 2, specifically for response time and percentile goals. Hopefully at a future date, we'll talk about these same issues with velocity goals. So I want to say that, there are some risks to fixing it, because to fix a goal, right, to give someone more resources, those resources have to come from somewhere. There's just not an infinite amount of thoughts from SUs or whatever resource the workload needs. So when you fix your high important workloads and tell them that, no, my response time goal really isn't a half a second, it's not even a quarter second, it's less than a tenth of a second, and he manages to that, somebody's going to suffer. Hopefully it's important 4 or 5 work, but those may already been pushed out of the system due to some sort of a cap. But just so you know, if I have a small importance 1, importance 2 goal workload, for example, that it's making its goal, and I have another large one that's suffering, and he tries to fix it, and he moves them above and below. If the change is not a major improvement for the large workload and it's major hurting the small workload, he'll back that change up. He'll remember it. So that's actually potential for another topic, but I'm just telling you that he does try to be reasonable about these changes, which is why impossible goals don't get fixed. And we're going to talk about those as we move on in here. So for those of you that are new to WLM, I'm going to give you a little bit of a review before we start talking about auditing and changing the rules. So one is we have to understand what WLM is really managing. It's managing just the flex-wide goals, not the specific L part. So you can have workload imbalances and service classes suffering on one L par and exceeding their goals on another L par. And the thought is that your sysflex distributor will fix this. It doesn't always. Some workloads aren't quite that dynamic in dispatching that things get moved around quickly. But you could look at, sysflex-wide goals and disparity, and there's ways of doing that in the OMEGAMON. He manages the service classes, not the address spaces. So he manages to the average of all the address spaces in the service class. So if you don't have homogeneous workloads, i.e., everybody wants similar resources, we could end up one could be suffering and the rest could be making their goal. An example of that is, you put all your CICS regions in a single service class, and one of them is CPU intensive and the rest of them are CPU light. The CPU intensive one will probably experience CPU delays, which won't be addressed. And the other thing that we want to talk about, focus on here, is the performance index. So the performance index is a way to normalize your performance goals versus your performance attainment. And we'll go into this in some detail in a moment. But WLM is attempting to, one means you made your goal. So he's trying to maintain your performance index in the range of 0.8 to 1.2. If it's below 0.8, he just totally ignores your workload. If it hits 0.8, he starts looking at you to keep an eye on you to make sure that you don't need help. And he often ignores you if your PI is greater than 2.0 because he can't fix it. He might have tried, but he can't fix it. So too loose is below 0.8, and too tight is above, typically around 1.8. So I mentioned WLM is using this performance index to normalize your goal across goal types. And I just mentioned to you exceeding, meeting, or missing your goal. But the different goal types have different formulas. So it is a velocity goal that we're not covering in detail here today, a high velocity, which is can I get resources when I want resources? The higher the velocity is, the better the goal attainment is. High response time would not be. So low response time is considered good where low velocity is not. So these have different formulas in math to make those performance index simple to understand. Am I making or missing just by how far is it away from 1.0? So just so we understand velocity goals, which if you have a choice of response time goal, you should be using WLM treats your workload differently. If your CICS region is being managed by a velocity goal, it's just like another batch job. He doesn't try to proactively protect you. He tries to help you if you're suffering, as opposed to a response time goal. He'll try to proactively help you before you experience the issues. But basically, it's, how often am I using CPU and potentially optionally IO, which IBM and I recommend that you don't use IO in your formula, but that is a migration effort, divided by, all the using samples and all the delay samples. It's basically an indication of, can I get resources when I need resources? A lot of customers picked values and pretended that this was a dispatching priority. Oh, my old dispatching priority was the highest in the system, so my velocity should be the highest in the system. Let's just make my velocity 90. I want resources 90% of the time when I ask for them. But that typically doesn't work. Most workloads run around 60%. Unless you throw IO in the formula, then it can get ugly. But a hard goal will make it so he doesn't manage to it. And I want to say, that actually using more resources equals a higher velocity. So if you have a CPU loop or you're doing a lot of physical IO instead of buffer hits, you're gonna have more using samples. That's all good. And we really don't see much in the way of storage or IO delays, paging and all that anymore. That was more of an issue 20 years ago. And ZOS doesn't manage IO priority anymore. It's handled in the hardware. So there's really very little point in putting IO in the formula. When you put IO in the formula, it dilutes the fact that you're experiencing CPU delays, and WLM may not try to fix it. So that's all I'm going to talk about velocity today. So we talked, this webinar is to focus on response time goals. And there are two types of response time goals: average response time and a percentile response. So an average response time is simple. That's what it says. It's a very simple average. So if you have a lot of really fast things and a few really slow things, you're going to have an average. May or may not be meaningful, but PI calculations are basically the actual response time divided by what your response time goal is. So this PI has a very wide range and a exact meaning. So 0.25 means you're 75% faster. 0.5 means you ran in half the goal, and 1.2 means you ran 20% longer. And like I say, if it's 2.0, then you ran twice as long. This is typically not the problem unless you have some significant outliers, and we're going to show you an example of that later. There, if you have a KICS response time goal and 90% of your transactions are sub-second, but every once in a while something ends that ran for 24 hours or 7 days, it can mess up your average response time goal. In which case, you'd be better off with a percentile goal, where you can say that I want 90% of my transactions to run within a specified response time, or 80, or some reasonable number. But when you do percentile goals, WLM puts all your response time into 14 buckets, and the smallest bucket is twice as fast as you pass. So therefore, your performance index will never be lower than 0.5, and you could be running hundreds of times faster, like I said, 20, 30 times faster, and all it says is that 100% of your stuff ran twice as fast or better than what you requested. So again, the buckets have a range, and on the other side, this PI is 4 due to the bucket, where on a normal velocity or an average response time, the max performance index is 100. So even though performance index is designed to normalize things, good or bad, the range can be drastically different based on goal. So just to go a little bit deeper into the percentile goal, WLM puts it in these buckets that I mentioned, and the buckets are there, and then he does calculations based on it, and OMEGAMON shows you these buckets, so you can see exactly what's going on. And you can see on this particular example that 88% completed that ran twice as fast as you asked for. They could have ran 12 times as fast or 20 times as fast. And you can see the actual response time and the response time goal on the screen here, so you know, and what we're talking about here in terms of goals that are too loose is specifically when you have a extremely high percent in they ran at least twice as fast as you asked for. Because what happens is somebody says, oh, good, I can steal from you if somebody else needs some resources. And this is where you see things like 30% wait for CPU for an important one workload, because it's still making the goal. The PI is still 0.5, right? So you need to understand that you could cut the goal in half and, the response time goal in half. Or you could look at the number and make the response time goal more close to what the actual response time is. And it would fix this workload from the risk of it could go, 20 times worse response time. Of course, when it does hit that risk before that it didn't address it and now addresses it, whatever workload it was trying to steal the resources won't get it, and something else, will put down the line. So the risk is a lower importance workload will suffer, but you told WLM it was a lower importance workload. So theoretically, that's what you wanted to have happen. Right. So that's the end of the overview of how WLM is working and how you can see some issues. But now we're going to talk about some actual examples, some policy issues, and how you can find them using OMEGAMON. So, we're looking for the one audit your policy for common risk. And the risk is you can have erratic response time. And I see things where like 80% of the time, 100% of the transactions are running twice as fast as the goal. But the other 20% of the time, it can get as bad as, it's actually running at the goal, right? Because that's what you told WLM to do, which may be 10 or 20 times worse than what you really wanted. So, if your performance index is regularly below 0.8 and you have a high percentage of your work in WLM bucket 0, which is less, it's running more than twice as fast as you asked for it, you're at risk. Now, there's a lower risk if it's CPU critical, but doesn't eliminate it. And ZOS 3.1 is making it the default, and personally, I don't recommend it. Peter Enrico doesn't recommend it. A lot of people are kind of questioning it. But it is a quick fix to say that importance 2 won't hurt your importance 1 workload because you had a bad goal. I'd rather fix the issue than put a Band-Aid on it. High non-achievable goals. Right? Your performance index is regularly greater than 2, even when the LPAR is not busy. So if you're looking at your machine and it's 40% utilized and some workload that you have a goal on, doesn't matter what the response time or velocity goal, and the PI is greater than 2, it's probably not attainable goal. It might be 0.2 when you're running at 100, I'm sorry, 2.0 when you're running at 100%, but it shouldn't be, above 1.2 when the LPAR is low, otherwise it's unrealistic. Another potential reason is the service class is too large, too high of a percent of CPU capacity. You can't fix it because if you put it above something else, everything else will really suffer. In other words, an insatiable appetite with a lot of CPU delay, and if you fix it, everybody else would be unhappy. And, you may have a velocity goal with I/O in the performance, which totally skews the numbers, but you can't just turn I/O off. When you turn I/O off in the formula, you need to pick a new velocity goal. And like I said, we're talking about velocity goals here, but and you've ignored hardware changes. I/O priority, SRM coefficients have changed on you, which changes aging. You're running DB2 high performance DBATs, and they changed the way they work about 2 years ago with a PTF right in the middle of the release, which affects, your DB2 goals. You need to pay attention to your WLM policies. So, easy goals equals risk. Your goals are most likely obsolete. I know many of you are kind of afraid to touch them. You don't think they're broke. You leave them alone. But WLM is 30 years old. Some people went with the Cheryl Watson quick start policy and never even tweaks it. It doesn't match your workload. It doesn't match your applications, response time. So let's just take a quick look at them. So one of the things we want to look at is response time goals. Now, this screen may look a little different to you than the one you have. There's a new view, which will be available in January of 2025, or you can request it earlier, and we'll show you how to do that at the end. But the columns have been resequenced, which some of you know how to edit your views and user views to do that. And a filter has been applied so that we're only looking at response time goals instead of response time and velocity, which is the current VA version. Anyways, your high important workloads, if they have, greater than 90% in the 50% bucket, they're at a high risk of being stolen from. And we have a workload looks like that here. All right. And any workload, unless it's CPU critical and defined, can be stolen from a lower priority workload. But all workloads all the time can be stolen from another workload of the same importance. And I know a lot of customers where they put, 90% of their workload is important to one, or 90% of their workload is important to two. There is no important to one. In which case, you've tied WLM, and you might as well make everything important to 5 because there's nobody to steal from. Everybody is equal. He needs to be able to steal from somebody. So we want to come in here and take a look, and here, in this particular case, we have a average response time goal of 200 milliseconds, which is 0.2 seconds defined in the policy. And WLM knows that it's 100% faster than you requested. It's at least 0.1 because you put all of them in this bucket. But if you look at the average response time, transactional length time up here, you can see it's actually 0.002. So there's your goal, and there's your actual. And WLM will not step in until your performance index is greater than 1, actually maybe 0.8, but your actual response time could get 100 times worse on this workload. So is that happening? Or am I having the problem? So within OMEGAMON, you can just simply type P and go to the historical trends for the workload, and you can see the average response time that, for the most part, it's really good. And occasionally there is something ridiculous in here that causes a problem, but still 90% have completed in twice as fast as the goal. So you have some really bad outliers here, and there should really be a average, a percentile goal instead of an average goal. Right? If you didn't have that outlier and you just had the 90% and the response time was always like this 0.008, you just change your goal to have him step in and manage it instead of donate, CPU and cause you to experience CPU delays because you said he could. Right? So I went to the right to see what was going on when I had the ridiculous response time, and I had 11 transactions that completed more than 4 times longer than what I had expected, and they're skewing the average. So this is an example of 2 things. One is most of the time you've got 90+% that are making your goal twice as fast as your goal, and you have a couple outliers that say this should really be a percentile goal. So that is, well, before I jump to the next, you do want to look at what's going on, trending. That trending thing is important. Just looking at things in real time is not, the perfect idea. When you go to look at a response time problem, you're probably not going to see, 100% running, twice as fast as you requested it. You want to look at a low period. You want to trend the whole day to see when does it make the goal, when does it miss the goal. But I have a lot of customers where, for 1 hour during the day, that bucket goes from 100 to 0%. And the question is, how many times, in this case, 100 times higher, how many times worse is your goal than your actual? Because that's how many times worse the response time is. So the other side of the coin is unattainable goals, right? Flying into the sun and having your wings melt. So, you've had application changes, you've had software changes, you need to review your goals. So here is the, same transaction. Here it is having a performance index of 9 times worse than you asked it for it, because you had one of those outlier periods where even though 90% of the transactions made the goal, the average response time was, higher than the goal. So the response time was 1.964 on average because, the way I pointed out a moment ago, outliers. So you did hit the risk. You did have something that didn't make the goal. He can't deal with this, which means he's not trying to fix anybody else. And here's the trending with a bad performance index with the transaction elapsed time, and still I have 90% except for in a couple of cases. Here's 85, 87, 83. So, but that's just half of the goal. And I don't know if you remember the formula I showed you before with the buckets. If I had in the 60 and 70 and everything, if I had some transactions in here, and the sum of all these buckets added to 90%, you could say, I want this response time 90% of the time. In this particular case, they're not. So you need to have a goal of 80% of the transactions complete in the goal, because it fell as low as 83 here, and there was nothing in these buckets. Your workload might look a little different. You might have some stuff that are, all the way up to the 1.0. And they add up to 90%. And you could say 90% of the transactions less than 200 milliseconds. So the performance index is bad in every interval, even with low power utilization, horrible average response time, outliers, but we have 83 to 90% completed and half the goal. Convert to an 80% less than 200 milliseconds. The PI will be 1 or less, and you'll attempt to manage it. Or eliminate outliers from being included in the service class. So, depending on how you're defining things and how these outliers are happening, right? But we have, a handful of really ugly, really long transactions. Some people do MQ trigger transactions where they get batches of, tens, hundreds, or thousands, whatever, of updates from distributed that get processed in a single transaction. Then when it ends, it's, way outside your goal. Just don't put those in, classify them in your response time goal. Classify transactions, the handful of high volume transactions that have consistent response by matching the goal. And I say high volume to make sure there's always samples of them for W. So with that, well, how do I test my policy? So my policy wasn't tested. And the reason your policy wasn't tested was, you always roll out your policy changes in low period. And WLM only takes actions under stress. So there's no stress. So the first time you're going to test your policy is when you hit high seas. All right. So, you can try to test them on test alphas, but the workload's not the same. And production is rolled out in low periods. So the policies are tested when the resources are constrained, which is in high season or when caps are hit, especially if you're using variable capping. So how do you test this? Well, you have to test it on production. So you rolled it out in low season, right? And, changing caps is pretty easy to dynamically do. You lower your cap to your current consumption slightly below. Make sure when you do this that there's some important 4 or 5 workload out there that it could hurt, and watch what it does. And if you're wrong and you have a bad thing like a loose goal and it starts hurting high levels, you just take the cap and put it back to where it was, or if you didn't have one, you remove it. So I highly recommend that you test your policy instead of waiting until high season when it's tested, when you don't want it to be tested, when you want it to know that it works. So with that, I want to say that with this webinar is going to be posted out on YouTube. You're probably watching it now. You can watch the IBM blog on OMEGAMON if you want to find it's under AI Ops and Monitoring Observability. If you do a Google search, and I do mean a Google search, some of the other searches don't honor this site farm, but with this search today, with the Google search, it will come up with the second option is, the first one's an IBM one, but the second option on the hit list is this. Click to this, click on the blog entries, and you can see other enhancements that have been delivered recently, in this case, last month, and more information on this particular webinar. And you will be able to get these new views, response time views, in one queue of 25, or if you open a case now and tell them that you want the WLM workspace update to that view, and there's actually one other view as well, but that will get you the right thing. They'll send you it, and it's the two files go into your user view, the menu folder, and so you can just delete them. It's not going to be put on via PDF in this case, and it doesn't, it's not going to cause any harm. It's just the resequence a column and hide column type of a change. So if you're interested in other OMEGAMON videos, the whole collection is out at this website in the bottom right-hand corner. Sorry. Thank you for your time today, and hopefully you take a look at the blogs and enjoy this video and find some savings and eliminate some risk without buying hardware upgrades or raising your cap to fix your important workloads.